record. So we're finding inverses again. So that's what today is. So we're going to do inverses, but these inverses are often going to involve logarithms. And just when you thought that you would never hear that word again, yes, not true at all. So not every question in today's notes is going to involve logarithms. Not every question in the next assignment is going to involve logarithms. Um, but we're still going to make a little parenthetical here in our notes that we are using logarithms. And you guys may not remember, but logarithms have a really nice property when it comes to freeing things out of exponents. And so we're going to just get right into it. And then as we do it, we'll do, you know how I am as a teacher. If we do enough drill and practice with it, eventually all those kinks should get worked out. But right away, you'll kind of feel the burn on this one. So our first example is f of x equals the quantity of 8 e to the x closed quantity all to the power of 1/3. From Algebra 2, I'm going to throw this out there. Do you guys all remember that the natural log of x is the same as the log with a base of e? It's been a hot minute since you've done logarithms, I'm guessing, but logarithms can have different bases. And when we specify e as the base, then we call it a natural log, ln. That's going to be super useful throughout today's assignment. You might remember the basics of logs, and you don't. This is not intended to be a lesson on logarithms, but can anyone tell me like what log base 3 of 81 is?
9?
Nah,
No, 3.
no, 4. Do you guys
27.
generally remember that the way the relationship works is that the base of the logarithm, when raised to the power of 4, is equal to the argument of the logarithm?
Oh,
3 to the
yeah.
4th equals 81. Is that ringing any bells? Okay.
Because 3 times.
So this, I have no idea how much like mud we're going to have to walk through to get to where I want us to go, but let's just dive in. Let's just go. So we're going to find the inverse of this function. And as you know, the first thing we have to do is replace f of x with y and then invert the x and the y. So we're just going to cut right to it. And we're going to just write it as x equals the quantity of 8 e to the power of y, all raised to the power of 1/3. So as we've been doing, we kind of did two things at once there. We swapped out f of x with y, and then we also swapped our x and y to get the inverse. So this is the inverse, but our job now is to get it solved for y so that we can actually write it in function form. So as I pour coffee, what would you say is the first thing that we would want to do?
Get rid of that one.
Yes, good instincts. We have to get rid of the 1/3. And how do we do that?
Multiple.
We raise it all to the power of 3. So like this side would have to be raised. This side would also have to be raised. And what that accomplishes is it gives us x to the third equals 8 e to the y-th. And the 8 e to the y-th is now out in the open because the parentheses were just there to sort of enclose it with that power. With the power gone, they're like, we're no longer needed. Everyone's free to move about the cabin. So follow your basic algebraic instincts. If you know the mission is to get y by itself, what has to happen now? You got to divide both sides by 8. That's just algebra 101. You recognize that this thing in the yellow jelly bean is called the power. And we have enough experience to know that that has to be gotten by itself before we proceed. So we're going to divide both sides by 8. I'm going to do a side change now. So I'm going to say e to the y-th is equal to x cubed divided by 8. This is going to be the part that we're either going to just blow right past, or this is where we're going to get stuck in some seriously thick mud. What we're going to do now is we're going to take the natural log of both sides. And this does feel an awful lot like an Algebra 2 sort of flashback. So here it goes. It's going to look like this, the natural log. And I'm not going to show this much work next time. So I'm just going to show you kind of the behind the scenes glimpse of what's happening here.
Wouldn't it be y to the power of x divided by cubed?
Hmm? Are you jumping ahead? Is that what you're doing?
Maybe.
No, I don't know. Is everyone okay that do you vaguely remember that we can log both sides of an equation whenever we want? So I have applied a natural log to both sides. I have said the natural log of the left side must be equal to the natural log of the right side. And it's at this moment that I feel like it's incumbent upon me to tell you when and why would I use a logarithm. Whenever your exponent that you're trying to solve for contains the variable, or I should have said this differently. Whenever the variable you're trying to solve for is hidden up in an exponent, the only way to get him down is to use a logarithm property. So some problems today, like as you'll see in the third example, will not involve logarithms, but some do. That's why the need for the log arises. And again, I would be crazy to think that you remember this, but there's a property of logarithms that allows us to take this y and move it down in front. Is there any chance that you actually remember that property? It's the single most powerful reason why logarithms have to be learned in high school math is because this y that I'm toying around with right here, that's a problem for me. Like, how am I supposed to solve for something when it's hiding up in the tree? Well, by having a logarithm applied to this side, I am now free to take this y and go like this. Oop, drop it down in front. It's the entire reason we logged both sides is to enable that one little moment in time to do that. Any chance any one of you remembers the value of the natural log of e? Did you just say one? Yes. The natural log of e is like the log base e of e. And from the Department of Redundancy department, if you have a log with the same base and the same argument, the answer has to be one. Therefore, this yellow box can go away, leaving us with our final answer, which is that the inverse function, y, is equal to the natural log of x cubed. That would not have been possible if we did not log both sides, enabling us to pull the exponent down onto the earth level where we could then tinker. Is that a little rough or a little easy? We got a whole sampler platter of these to work through. Here comes your next one. Your next function is f of x, and it's going to be e to the power of the fifth root of x minus 7. This problem is so much easier than you think, and until you remember logarithms, it's impossible. I shouldn't say that because there's some professor in like Vermont might watch this video someday and go, I need to contact this Jeremy Ahern. It's not impossible, like with his pipe hanging out of his mouth. Fine, not impossible, but holy smokes. So what we want to think about is, well, let's first do the thing we do. Let's take the y and the x and let's switch them. You know, it's kind of annoying, but it's what we do. So we're going to take x and y and switch them. And we're going to say x is equal to e to the power of the fifth root of y minus 7, like this. The fact that your variable that you're trying to solve for is in an exponent, this is not about the fact that it's in a root. I don't care about that. I care about the fact that it's hiding from me. It thinks it's safe up there in the exponent. We have a tool for this. What is our tool to bring him down? The log. And in this specific case, we want to use not just any log, but a natural log, right? So we're going to, again, natural log both sides. So we're going to natural log the left like this. And we're going to natural log the right. This will probably be the last time that I show this step to the extent that I'm about to, because I feel like if I'm any good at this job, I will have succeeded after this one more iteration of this process in convincing you of why this works. What did logging just now enable us to do?
Yeah.
It allowed us to take this exponent and move it down in front. If If I haven't made that clear, let me try again. That is why we log in equations, is because someone that we want to tinker and play with is hiding in an exponent. And the only way to bring them down is to apply a log and then be able to apply that property of logs, that one beloved property. And what's always going to happen is if I play my cards right, I'm going to find this redundant log. What is the natural log of E again? One. And the point of multiplying by one is exactly right. None. Pointless. It really allows you to just take that one side, that right side, and just crush it down so that the exponent really just becomes the only thing on that side, understanding that the log just kind of killed itself out. And at this point, we're looking pretty good. The Y and the 7 are not yet free to move about the cabin, but we've made some great strides here. What's the next thing we want to do? We want to raise this side to the power of 5. Understand that that is not the natural log of x to the 5th. It is the natural log of x to the 5th. Massive difference between the two. So make sure you parenthesize that whole quantity and raise it to the 5th power. And then, of course, when we raise this size to the 5th power, what happens? They just cancel out, right? And so we're in a really good spot now. So we have the natural log of x raised to the 5th power is equal to y minus 7. And then basic algebra kicks in and you realize we're done. So our final answer in this case would be that f inverse of x has got to equal the natural log of x raised to the 5th power plus 7. Okay. I want to show you an example now of what I was saying. I made reference to this earlier, that not all problems require logarithms. I don't want you to walk away from this lesson thinking I need logs every time. I said this earlier. It's not true. Specifically, you need logs when one condition is met. What's that condition again? What makes me say logs? If the variable's in the exponent, in any form, inside a root, outside, if it's in the exponent, you're going to need a log to get it down. Okay, let's do this. So our next example is going to be that the function f of x is equal to the quantity of 8 y to the power of 1/2 minus 3 closed quantity raised to the power of 7. And we want to invert this. So step one is to replace f of x with y and then switch the x and the y. Steps 1 and 2, we've sort of just melted together into one step. So we're now going to say that x is equal to, by the way, when I wrote this down, I didn't mean to put a y here. I meant to keep this as an x. I was looking at my note card where I'm jumping ahead of myself. Apologies for that. The original function should have, of course, had an x there, not a y. Okay? Make sure we're clear on that. And now, again, I don't ever write them down fully. I just skip steps when I'm preparing problems for you guys. So this is now 8y to the 1/2. Now it's switched minus 3 to the 7th. You can see that there's no need for logarithms because the one condition is not met, right? The exponent or the variable that we're trying to solve for is already down on Earth level, so we're good to go. What is step 1?
Root by 7.
Yes, let's take both sides and apply a 7th root like this. We understand that what we're really trying to do here is get all the stuff that I've underlined in red to be free to move about the cabin. Like we're not going anywhere if he's trapped. So the 7th root will accomplish that mission. So we're left with the 7th root of x is equal to, the parentheses are no longer needed, right?
Mm-hmm.
So we're going to have 8y to the power of 1/2 minus 3. And you'll find yourself skipping both of the steps we're about to do. I wouldn't be surprised if already sitting here, 4 or 5 of you are thinking, I already know what I'm about to have to do. And your next step, you might have already added 3 and divided by 8. But algebra never changes. Like algebra is predictable. It's repetitive. The language of algebra doesn't change. Even when you get into like your 3rd year college math classes, algebra is just a language. It's just a set of rules, right? It never changes. The goal is to get this yellow jelly bean by itself. And that means, just like I taught you back in algebra 1, you add 3 and then you divide by 8. I'm going to do a side change now. So we're going to have y to the power of 1/2 is equal to the 7th root of x plus 3, all divided by 8. You would agree in this case, again, there's absolutely no need for me to apply a logarithm. So what's our final step?
Raise everything to power two.
Raise everything to the power of 2, and it's done. So we would say finished product here that f inverse of x is equal to this whole thing from up above raised to the power of 2. So I can cheat a little bit and just pull it down in here like this. Cheater, cheater. I've got more examples. I felt I got kind of kid in a candy store vibe going. So let me just maybe pick like one more. And then I think the best way, as always, to learn math is just to do it. And then let me kind of be involved if you have questions. Uh, I couldn't really pick like one of each, or it would have taken like 2 full class periods. So uh, let's do this one. F of x is equal to e to the power of the fourth root of x, that locally divided by 3 and then subtracted by 7. So there's a function, and we're going to invert it. And step 1 is to get everyone in place, switch the x and the y. So it's going to say x plus 7 equals e to the power of the fourth root of y over 3. I slipped one in on there on you there. Are you cool with it? Are we to the point where we can do those little things like adding
Yeah. Yeah.
as we go, kind of, right? Save some time. All right, let's get to it. What's the next thing we would do? Multiply by 3. Again, algebra just never changes. If you multiply both sides of this equation by 3, we wind up in a pretty good spot. We wind up with e to the power of the fourth root of y being equal to 3 times x plus 7. And 30 minutes ago, we would have panicked. But now we're reminded of this best friend, this guy that at one point in our math careers was just this annoying thing that Mr. Ahern made us learn. But we now maybe are starting to realize it's a very powerful tool to carry in your toolbox. The power of how do I use logarithms to make myself stronger, right? So we're going to natural log both sides. So we're going to natural log the left side, and it's just going to say the fourth root of y is equal to the natural log of 3 times x plus 7. I told you I was going to do this, and I did it. I kept my word. Notice I didn't ever show the log on the left-hand side because I saw the writing on the wall. I knew that natural logging had a purpose. It was going to kill that e in, right? Why write it down? You know what's coming. What's the last thing we have to do? Power 4. Exponentiation is going to be what we want here. So we're gonna finish it off. We're gonna say that y, or let's say f inverse of x, is equal to this whole thing raised to the power of 4. And again, since I have this technology, I can cheat a little bit and I can just put that right in there like that. The question that I would ask if I were sitting in my class right now would be, should I multiply the 3? And I had that same question when I was working this. I like to sometimes usually work the problems before I work them with you. And my answer would be this. This is a multiple choice question, so it's not going to be up to you. So like if you're scanning on Delta Math later and you look and you don't see this, a good reason for that might be that this was written as like 3x plus 21. To be mindful of that. And we've talked about this, that on multiple choice, it's not always up to you to be bossy about how things look. So in the interest of not putting you all to sleep, I'm going to pause this here. The recording will still be alive. I'm just going to pause it. You guys are going to get to work on your Delta Math. And then when you get questions where you're like, what the who, then we can do them together on the board. Deal?
Yes.
Rad. Okay. Andy, will you read me your original, like what it said?
Yeah. 4 to the 4 to the root
The fourth root of. Okay.
of 4 to 3 parentheses x minus 2.
So the reason I want to talk to you about this is because we have to use a log here. but we're not going to use a natural log. And I apologize if I'm wasting your time, but the thing about this is let's go through the normal motions first. So let's do our swappy swap. So we're going to have x equals the fourth root of 4 to the power of I don't know how quickly I want to go. Let's call it 3y minus 12. You guys okay with that?
Yeah, that works.
I realize some of you aren't listening. And I'm okay because I understand that you're working, but I am just trying to help you. So, we're going to take both sides and raise them to the fourth power. This is all stuff that is easy. So you're going to go x to the fourth power equals 4 to the power of 3y minus 12. And this is the part I finally wanted to talk to you about, and it's this. You know we have to log both sides, right? What kind of log should we use? And again, I'm bummed that only literally 2 of you are listening right now and everyone else is ignoring me. You're going to have this question eventually. You should totally get this. What did you say? Yes. We want to use a log that will always match this number that I'm circling in green. You need to understand that we want to create that redundant situation where the log will effectively cancel itself out. I'm going to show a little bit more work this time. I said I wasn't going to do this, but that was in the context of natural logs. I want to show you what this looks like. We're going to take on the left side and we're going to do a log with a base of 4. And we're going to say log base 4 of x to the fourth. And on the right side, we're going to do log base 4 of 4 to the power of 3y minus 12.
And then that you can bring it down.
Right. And the question is, well, why did you do that? The answer is because if I bring this down like this, then what I've created by choosing a log with a base of 4 is I've created another redundancy. And I hope you come away from these few minutes that I've been talking your ear off and understand that the log base that we choose should match the base that we want to effectively kill. Because what is log base 4 of 4?
1.
1. Log base anything of itself will always be 1 by definition if we understand anything about logarithms, which means now that by choosing a log base 4, we can effectively just have that go bye-bye. Do you see that? So you think you got it from here, Andrew? Okay.
I just got one because one of the roots wasn't far. Like it was. I wish I could go back, but it was like the answer was like root 3, and then the spiel +7.
Yeah.
And then there was a root over the plus and answer. So
I will say, having clicked through some of these earlier today, I clicked through maybe a half a dozen or 8 of them. Their answers that they put in as wrong answers are often quite tempting. So I think whoever wrote it, like obviously I don't think these are computer generated. I think these were human created. They didn't just randomly put like the right answer and then a bunch of crap. Like the wrong ones are supposed to look tempting and tasty. So I would recommend that you be using paper and not trying to do these in your head. Just my advice. You good now? Does that make sense? Okay. So let's leave this as 3 times y minus 4. And then we log base 4 to both sides. And then this side will now still say 3 times y minus 4. So, and that's a good test taking strategy for like ACT or anything else, is to say, I know what I'm doing. I just have to examine my process to make my answer go the way they want it to. So from here, Andrew, what would we do next? Divide both sides by 3, right? Dividing on the right side by 3 renders the parentheses pointless, which is always the goal. Like we don't want parentheses to need to be there. They exist when they have to. So we're left with y minus 4 equals log base 4 of x to the fourth divided by 3. So I would think at this point in time that one of your answers would hopefully be log base 4. Correct. Is that one of your options? Gorgeous. So that's what's nice about multiple choices. It kind of bosses us and leaves freedom of choice kind of out of it, which isn't always a bad thing. So I'm not resuming it to lecture you about math. I'm resuming it so that if Julie or Sutter are watching this, they'll know that you're going to get more time in class tomorrow to work on this. Got it? So let's work hard for 5 more minutes and then we'll pack up and be done. Yeah, you can have more time in class tomorrow. Oh, and a math question at the same time. Well, then let's get a math question also.
F of X is equal to 8. I don't know if it's
Let me pull up your screen and then I can kind of read it. So it looks like we have 8 to the power of. So we have 8 to the power of some fraction. That looks really confusing, I understand. And then the fraction, on top of the fraction, we have the fifth root of x minus 9. So understand that this whole thing that I'm moving my pen around is just one big exponent, right? Okay. So we're going to have x equals, yeah, I mean, I hate to copy all this down, but I'm going to do it anyways. Oh, and believe me, I know, and I'm trying really hard to ignore it right now. I just have to do this problem. Okay. Thank you. I appreciate your assistance, but I just want to get this done. So yeah, you're right. We're going to log in more specifically. What did you say? Log base 8. Good for you. So we're going to wind up over here with log base 8 of x. And then over here, we're just going to have the fifth root. We're going to have a fraction on the right-hand side, but this 8 is going to essentially go away, right? You get that? So my right side now is just going to say a fraction, and the top of it is going to be the fifth root of y minus 9, and the bottom of it is going to say 5. So the rest from here is going to be, I think, pretty simple. Just because from here, it's just going to be some basic algebra. So we're going to start by multiplying both sides by 5. You would agree? So we're going to wind up with the fifth root of y minus 9 is equal to 5 times the log base 8 of x. Still good? And then from here, there's 2 things left to do. In order, what are they? Right. So we're going to raise both sides to the power of 5 like this. And then these 5s over here are going to cancel out. And the y and the minus 9 are now like free to move about the cabin, right? And I did not add the 9 because I didn't want to just yet. I wanted to talk to you a little bit. So we're going to wind up with 5 log base 8 of x raised to the power of 5. There's no way that whoever wrote this problem wants you to put 3,125. I can't imagine that they do. Like I've noticed throughout this, like there seems to be a consistent pattern here that we're leaving things sort of unsimplified, if you will, or undistributed, unmultiplied out, however you want to say that. So I'm just guessing here that your final answer is going to be f inverse of x is going to equal this 5 log base 8 of x to the 5th power plus 9, like that. Did that make sense?
Yeah, it makes sense. There's just options that make sense. So it'll be
Well, that's, I think, why they're doing a good job. That's why I allowed this assignment to get through. When I go to Delta Math, if I think it's garbage, then I'll go elsewhere, like paper or different software or something. But I liked how they made their wrong answers look tasty. I think that's how you should do it. It's the best.
because there was one with this 5 set of brackets, and then all log x
Right.
to the 5th.
Yeah.
Not log.
And again, it's not one right answer and 3 hilariously stupid answers.
Yeah.
It's one right answer and 3 answers that you could make a case for if you're cutting corners, right? Okay.